Monday, the 12th of September, 2022, and this is a Cluster API community special deep dive meeting. We're going to look at the Cluster Autoscaler and in specific what the balance similar node groups option does. So to begin with here, I'm going to share my screen and we'll take a look at the FAQ from the Autoscaler. And this is generally where I direct people to look, first when they have questions about the Autoscaler. And if anybody has questions during the meeting today, feel free just to kind of raise your hand or interrupt me or whatever. I'm not gonna stand on too much circumstance or ceremony. So anyways, one of the questions in the how-to in the FAQ is about running nodes for HA purposes in multiple zones. And it talks about this flag called balance similar node groups that was introduced quite a while ago in the Autoscaler. And this feature is something that, at Red Hat, we get asked about with pretty regular frequency. We have many users who seem to like using this feature. I wouldn't say that everybody does, but it's probably one of those things where, 40 to 50% of users ask about this feature. And what this feature allows you to do is to tell the Cluster Autoscaler that when it is attempting to scale up, because it will only do this during scale-ups, that the Cluster Autoscaler should try and create nodes amongst node groups that are similar to each other. And so when the Cluster Autoscaler is attempting to scale out, it's attempting to grow the cluster, one of the first things it does is a sort of bin packing algorithm to try to figure out what the best node type for expansion would be. And it does that based on the pods that are pending, and then it looks at kind of the capacities of the different nodes that are there. It also looks at things like selector labels in case the pending pods need, special requirements and whatnot. And then the Autoscaler will make a choice based on that. If you have this flag enabled, the Autoscaler will attempt to find similar node groups when it wants to expand more than one node. And so, what are node groups and what is similarity between them? So internal to the Cluster Autoscaler is a concept that it calls a node group. And this is not exposed in a CRD. It's not kind of like given anywhere where you could look at them. But for each provider that the Autoscaler uses, every single provider has the concept of a node group. And this is a grouping of nodes that have similar capacities, or perhaps they have similar labels. All the nodes within that node group will be the same when you create them, meaning that they'll all have kind of the same topology. They're all expected to have the same labels and taints on them. So when the Autoscaler looks at all the node groups it has, it can then make decisions about these. And, every provider has a different notion of how to group node groups. In some cases, like in the case of the AWS provider, they're able to use AWS autoscaling groups internally, and it's able to do a lot of manipulation directly with the cloud. But because Cluster API, is kind of like an abstraction to many clouds, then necessarily our node groups have to be more abstracted. And this is where I find working with Cluster API with the Autoscaler to be kind of easy, because in general, Cluster API machine deployments or machine sets, if you're just using them correctly, map one-to-one with node group. So in Cluster Autoscaler, if I have two machine deployments and both of them are doing autoscaling, then I could assume that each one of those is a node group. So if they both have the same infrastructure machine template behind them, then they will look like similar node groups because they'll have the same capacities and they'll look kind of the same to the Autoscaler. So there's a couple primary tests that the Autoscaler looks at when it tries to determine what are similar node groups. The first are the capacities. So this is like the CPU, the memory capacity. In the case of special resources, there might be GPUs or networking, special networking cards that have been added, and it will use those to try and compare the node groups. Yeah, Fabrizio, you had a question. Go ahead.
At least me doesn't hear Fabrizio. Same for others.
Yeah, I'm not hearing Fabrizio either. I do see you are unmuted though, Fabrizio. I'm going to stop sharing for a second here.
Can you hear me now?
Yes, I can hear you.
Okay. Okay, so making question may be silly one. So I guess that what are the story is we are deploying the autoscaler that at the end is a new controller with its own stuff. And the flag that you were talking about is a flag that goes in the autoscaler deployment. Okay. The missing, maybe I'm making a really silly question. Now you are talking about, okay, what is a node group in Cluster API? The missing bit for me is how I declare that a machine deployment is an autoscaler group.
Yeah, that's a good question. So our implement, and you're right at some level. I'm going to go back to sharing because I'll show you where this is in the code. The autoscaler, yeah, it is kind of like a controller, and it's just kind of reconciling records in the case of Cluster API. So if we go back into cluster I'm in the autoscaler repo looking at Cluster Autoscaler, cloud provider, Cluster API, and this is where all of our documentation is. When you add the annotations, when you add the scaling annotations to your machine deployments or machine sets, this is how the Cluster Autoscaler will identify those node groups. So it is reconciling all machine deployments and all machine sets, and when it sees these annotations present, it knows to include that node group in autoscaling. Does that answer the question, Fabrizio?
One question.
Yeah.
And the capacity information that you just mentioned, that it needs to group or get the attributes for a node group. It was just saying from the capacity annotations, right? Like the ones below directly.
Well, right, yeah. So like those can either come from the capacity annotations, or now, since the scale from zero change has merged, they can also come from the status capacity block of the infrastructure reference, right? So the autoscaler will attempt, if it sees an infrastructure reference, it will attempt to get that record, and then it will look to see if there's a capacity block. If there is a capacity block, it will use that. If there are annotations, it will use the annotations as an override.
Yeah, sounds good. Now I remember the process. Yeah, got it. Makes sense.
Cool. Abhijit, you had your hand up as well.
Yeah. I have one query. So if I have a cluster deployment which has two node groups, but in two different zones, would I be able to identify if a pod is pending in a particular zone and the cluster autoscaler could only scale out that zone? The machine deployment definition could be the same across the two zones. So how is that identification carried forward to the autoscaler and then applied to the right node group?
Yeah, that is a great question, Abhijit, and I am just getting to labels because labels are the other part of how the cluster autoscaler attempts to match jobs, right? Or attempts to grow the cluster. So if on the pending pods there are labels that are needed, and those labels can be satisfied by a node, the cluster autoscaler will attempt to make those. But in most cases, the zone labels are not necessarily required by the pods, right? Like it's usually rare that a user would create a pod and say, I need this pod to be running in this zone. It's certainly possible that they could do that, but they don't necessarily need to. So there are what are called the well-known zone label in Kubernetes. And when the cluster autoscaler starts getting into looking at balancing node groups, there is a piece of code that is called the node group set processor. and this is, I'm getting deep into how the autoscaler looks at these things now, but there's a group of what are called processors, and these processors customize the behavior by which the cluster autoscaler can look at things like node groups and node info. And this node group set processors are what the autoscaler uses to do some of these deep comparisons, right? So in the case of zone labels, right, oftentimes when you're attempting to balance the nodes between them, you don't actually care about the zone labels, right? But the autoscaler will consider two nodes different if their labels don't match, right? And so if you have one node that's deployed in zone A and another node that's deployed in zone B, the autoscaler considers those to be disparate node groups, unless you get them to ignore certain labels. And that's where these processors come in. So this create cluster API node info comparator. This is a function that's used by the autoscaler when it attempts to do balancing operations. And it uses this to try and figure out what labels it should ignore. And this is kind of getting to the crux of the discussion we were having a few weeks ago at the cluster API meeting, because one of the things that I've been doing is going in here and adding more zone labels, or adding more labels that it could be aware of. So for example, this one here, topology.ebs.csi.aws.com/zone, that is AWS's well-known topology label for their block storage CSI driver. So if you have the CSI driver enabled on your cluster, your nodes will have this label on them if they're being used by that driver. But we need those nodes to be considered, we need them to ignore this label for the purposes of considering if they're the same. The scheduler will handle the persistent volume requirements, but these labels would cause it to look different. And similarly, there's a group of what are called the basic ignored labels. And these are, you see these used over and over again. Like if I look at the AWS node group, for example, you can see that AWS has its own list of things that it's ignoring. And then it also looks for the basic ignored labels as well. And so I'll try to remember if I can remember where those are. Yeah, go ahead.
One question. Is there another list somewhere in the beginning which essentially is a list of labels that the autoscaler cares about, and then you have to add have that ignore list so that it doesn't care about it, or does it just care about all labels on nodes that you have?
Right. It will just attempt to look at all labels on all nodes. And so
okay, that means if someone adds some labels in some way to a node, it means that you can't know about because it's just a totally different reason why that label is there.
Right, correct.
Then the autoscaler would start considering this another node group just because there's another label.
Right. Now you're jumping ahead a little bit,
sorry,
but I appreciate it because it allows me to talk about this next. I'll do a little diversion here and then we'll go back. So you're absolutely right. And there is another flag here called balancing ignore label. So if you have a situation where you have users who are customizing the labels on their node groups, maybe they have some special information that they want to keep, or there's some reason to demarcate two node groups as different from each other, but you want to make them the same in terms of balancing, you can use this flag multiple times when starting the cluster autoscaler to give it different labels that it should specifically ignore. So even if the labels aren't being automatically ignored by the node group set processors, you could still inject labels that you would like them to ignore. And similarly, you can also define a balancing label that you should use. This is a feature that was added more recently. So you can say, I want any node groups that have this label to be considered the same, regardless of what other labels are there. And so this was a feature that was added recently, that when you're using balancing similar node group sets, you could set this balancing label, and then the cluster autoscaler will ignore every other label and only look for those labels to make similarity. So that's kind of a little bit of a side look here into how you could supplement this on your own if you need to.
One follow-up question. And based on that, one machine deployment is always one node group in Autoscaler. You should probably really make sure that you don't screw that up by having different labels and then they're considered separate even though they're the same, right? I mean, if you just manually set some labels on your nodes and you don't add it here the right way, then you actually have only one machine deployment in one node group, but because of that label you get two, and then it's not really able to scale it accordingly because it just has one machine deployment to scale up and down.
Yeah, I mean, that could happen. You could do that. And likewise, you might have different reasons to use these balancing labels. Like you could imagine if you had 4 machine deployments in your set, in your cluster, and 2 of the machine deployments had label A and 2 of the machine deployments had label B, you might set this balancing label twice to designate that you have 2 different, topological groups. And when work is going to one group, you want it to balance between those node groups. And when work is going to the other group, you want it to balance between those. So there are a lot of complicated ways you could use these depending on the topology you're trying to achieve.
If I got it right, so let me say, standard behavior, the autoscaler balance between a node group. But if I enable this flag balance similar node groups, and then I play with these other flags, basically I can have the autoscaler balancing between many machine deployment at this point. Oh, that's cool.
Yeah, you absolutely could. And then think about topologies where we have people who are like, they have one group of nodes that's like machine learning related stuff. Maybe it has GPUs on it or something. And then they have another group that's like their database stuff that has high speed storage or something. If they wanted to make both of those groups highly available, they could make 2 machine deployments for each group, set the machine deployments in different zones, right? And then when they have workloads that flow to those machine deployments, yeah, the autoscaler will properly balance between the two. And I think just to
just one question.
Yeah, go ahead.
Yeah, so you just showed a list of the labels which are kind of ignored, right, or taken in. So do we still have to maintain that, or because we already have this the other way of passing it through the API, right? So is that list still required to be maintained?
So that is a good question, Abhijit, and it kind of brings us to where I'd like to end up here. So yeah, if I go back to the code we're looking at here, do we need to maintain this list? That's a great question, because one of the things I have up right now is I have a PR open to try to make this better. So one of the things that I would like us to do is I would like us to maintain some of these labels, especially the labels that other providers have called out as being important, because it makes the experience better for our users automatically out of the box. So if they, and I'm trying to, here's the list of labels that I'm trying to update currently into our yeah, hey, Jack. These are the labels that I think we should incorporate, and I'm trying to bring them in from all the different clouds that we cover. These are the automated labels that they use, and I'm kind of describing. Many of them are used by CSI drivers, or they're used by cloud controller managers, and they're just used to tell, like, this node is in this zone or this node is in that zone. So in general, the reaction from the autoscaler community has been to ignore these labels for the well-known like zone labels and whatnot. And so I've been bringing them in to try and create a list and, make sure that when users use the cluster API provider for Cluster Autoscaler, they kind of have this awesome experience out of the box. But Abhijit, I think your question is absolutely poignant. Like, we could decide not to maintain these labels for Cluster API, and then it would just be up to the user to set the balancing ignore labels whenever they were trying to use this. So, really, and we've only got about 7 more minutes left in the scheduled time slot. This is like a good place to be in terms of the conversation. Like, should we be maintaining these labels? Is this something that we want to do as a group, to try and make the experience more seamless for Cluster API users? Or should we just document, here's how you ignore these labels, here's how you configure it? Because certainly it will be much easier for us to maintain if we don't have to look at these labels in the node group processor. But that's at the cost of making this more complicated for our users. So, really that's kind of some of where the question is. Yeah, go ahead, Stefan.
I wonder if an allow list approach plus documentation would be easier than the other way around. So what I don't know is about which labels do we actually care. Labels in AWS,
right. So,
I mean, it's kind of the same problem, just the other way around. But maybe
right.
there are not that many labels that we have to care about. Maybe.
Yeah, that's kind of like up to the users, right? Like users are always, they maybe label some machine deployment as like, this is my super special deployment. So when I create workloads, they all have to go to the super special deployment. I mean, in general, it seems like the autoscaler community has tried to do, and this was easier for other clouds because like, on AWS, they only have a few that they want to maintain. But for us, because we work with all these different clouds, the number of zone labels that we might want to include could become very large, Going to see what Jack said here.
Yeah, I was just saying +1 to having a set interface. So you just comma separated string or something like that we clearly document.
Yeah, so the autoscaler does have that already. Right, it has a flag that you can tell it, you should ignore this label. So it sounds like what you're saying is we should maybe back out of like doing this auto-magically for you.
Well, that's just my vote, because I don't think that the downside of maintaining a set is huge. I think it's just really predictable that it will almost always be incomplete. And I guess you could argue, I'm leaning toward the argument that that's sort of misleading to the user. By even maintaining any set, you sort of suggest that we've got this under control, but I think that there's very little confidence that we will have this under control for any particular user. So I would have a slight preference towards just kind of asking the user to do that work as a way of actually producing a confident contract, Otherwise, it's just, yeah, that's just my view.
Yeah, no, I appreciate that. And, certainly this does not necessarily need to be in the code for the autoscaler either, right? Like if we develop Helm charts or, cluster class add-ons or whatever that deploy the autoscaler for you, like we could certainly encode this knowledge in those places as well, like when starting the autoscaler. This, the reason this came up for us is that at Red Hat, we do a lot of automated testing of the cluster autoscaler, and we do have a series of tests that we do with the balance or node group stuff. And so like, as we're now deploying Kubernetes with CCMs, we're starting to see another explosion of these like labels that the CCMs are using to designate some sort of zonal differences. And again, right, they could be ignored.
That's a symptom of all these CCM projects have been delaying enabling all these cloud provider functionalities for like 6 years. Like, we're going to wait until it's out of tree. And now out of tree's arrived because, all right, great, ship all the features. So now you've got a million features that come with CCM.
Totally. And, the CSI drivers and everything. So, yeah.
Mike, may I ask a question? So basically the problem arises only if the user opt-ins in this cross-node group balancing. Okay. So my comment is that there is, I see a problem, or at least a risk, in the current autoscaler behavior that consider all the labels. Because if I have a cluster perfectly configured and someone goes and apply a label on my node, basically screw up on my load balancing thing. So this is the biggest risk. So starting from this is the bigger risk, because I'm the administrator. I want to set up an autoscaler and be confident that my setup works from that moment on. So the behavior that the autoscaler consider all, I see it risky. I think that the recommendation that we have to give to a cluster API user is that if you want to opt in this feature, you have to pick up also the label that drives this behavior and set it explicitly. So your setup basically is less fragile. In my opinion, that's the best recommendation that we have. And if we go down this path, that we suggest to explicitly set up the label that drives this behavior, basically the ignore list becomes not required. Does this make sense?
I think so. Let me just repeat it to make sure I'm following you. So like you're saying the preference would be better to make the user explicitly aware of these labels that they need to know about so that they can absolutely be assured of like what the autoscaler is doing and there's like kind of no magic going on. And that we should just fully document this out and kind of show people like, hey, if you're working on this cloud, use these. If you're working on that cloud, use those. Is that kind of what you're getting at?
Yes, but I think that the main reason is that we should steer user away from the default behavior that consider all labels, because this is fragile. So if we want, let's say we want less problem, we want to steer toward less surprises. And less surprise is pick up your label. That's it. This gives you the less fragile option, in my opinion.
I think that's what you're getting, right? If you said that balance group labels flag or what it was, I think there was something like everything else is ignored then.
Yeah. Okay. Yeah, there's two ways to look at it. One way you can tell it to ignore labels specifically. The other way you can tell it to only look at labels and not look at anything else.
One question. The list that you currently have on that PR, how much controversial opinion is already in that list? I mean, it's something like that we wouldn't care about zones. I guess that's something that different people might see differently, right? That a different zone is already a different node group. I don't really know. Just wondering if that's already would work for everyone, or is more like, okay, it's maybe already, it's not very likely that will work for a lot of people because they just have already different opinions and everyone does it differently, etc. That would mean that it's hard to just add something hard-coded, which is kind of the best way to do for everyone.
Well, right. So like where this started is that in Kubernetes, there's like a set of well-known labels and annotations, and one of them is the well-known zone label. And so the well-known zone label is one of the main things that the autoscaler ignores, right? And so it ignores that by default, right? Unless you turn on the flag that allows it to only look at a certain label or specific labels. So right now, there are some of these that the autoscaler is already ignoring, ones that the community has agreed on, like, topology.kubernetes.io/zone. That's like, that's well known. The community has agreed to ignore that. Some of the other ones, like, for example, the CSI drivers, and I'll just note, we're over time here. So if anybody has to drop, please don't feel bashful. Some of the other things, like the CSI drivers, right? When CSI was first being defined as a spec, the various driver implementers had not yet agreed on the well-known zone labels, right? So that's why you see like AWS has their own zone label, right? And hence why the AWS node group set processor wants to ignore that zone, right? So like where this started was we started to automatically bring in some of the other labels that were being ignored by other providers. And you can tell as it's grown because of the testing that we're doing, like internally on, like IBM and Alibaba and these other cloud providers, like, we said, okay, maybe the cluster API implementation should have all this stuff baked in so that regardless of what you're working on, it works the way you would kind of expect it to. But it does introduce a problem that we're all identifying here, which is like now this list could just keep growing, right? We could always have to be maintaining this list. And so I think the wisdom there from what I'm hearing is like probably better to teach our users how this works, how they can enable it, and when they should enable it. And then we don't have to worry so much about having the autoscaler automatically do this stuff for us.
Yeah, probably good surprises. Agree. I mean, I guess every CSI driver nowadays has its own label. I just remember the one in OpenStack, for example.
Right, totally.
I don't know if we get everything in there, and if our users don't know how it works, then yeah. Not sure how likely it is that I do it correctly.
Okay, since we're over time, does anybody else have any comments before we kind of wrap things up here? Oh, I see. Well, Stefan and Fabrizio, you guys had your hands. Did you still have something you wanted to say, Fabrizio? Okay, cool. Thanks everybody for your time. I think this gives me some clarity about the direction we should take. And what I will try to do is I will try to start working on putting together the documentation for this stuff and backing out the changes that we have in the autoscaler now. So we can just make it a little simpler. We'll rely on the documentation, and we'll start with documentation in the autoscaler. And then I guess that'll get replicated to our API book as well, if I understand the process there. All right, cool. I'm going to stop the recording. Thanks everybody for coming out.
Thanks so much, Mike.
Thank you, Mike. Thank you very much.